The problem I had to solve was problem 19, which asks us to find the current going through this 6-volt battery in this circuit here. To do that, you need to use Kirchhoff's loop rule and his junction rule. Using the loop rule, you can get these equations down here. That I1 equals I2 plus I3, and I3 equals I4 plus I5. You start the current at a 10-volt battery, call that I1, and you go around the circuit. Every time you split, you make two new currents. So the first junction you split into I2 down here and I3 here, and then I4 down here and I5. I4 is the one we want to solve for. The next thing you do is you make 3 loops. The first one turning through this 4-ohm battery, this 4-ohm resistor. The second one through this 6-volt battery, and the third loop through the entire perimeter of the circuit. Each loop, the sum of potential differences across them should be 0, so use that knowledge to make 3 equations. The equations you should end up with are 18 volts minus 4I1 minus 4I2 equals 0, 12 volts minus 4I1 equals 0, and 18 volts minus 4I1 minus 6I5 equals 0. And you get those equations once again by going through these loops here and simply adding or subtracting as necessary based on the circuit that we're given. So with these equations, you can solve for I1 with this equation here, and once you know I1 equals 3, you can use that to solve for I2 and I5 and get 6/4 and 1 respectively. With I1, I2, and I3, you can then solve for I4. I1, I2, and I5, I'm sorry. Solve for I3 in this equation, and that gives you I1 minus I2. Set that equal to this equation, I4 plus I5, and then plug in your values. 3 minus 6/4, or 1.5, equals I4 plus 1. 1.5 minus 1 equals 0.5, and so that's your final answer. I4 equals 0.5 amps. Once again, we did that using Kirchhoff's loop rule and his junction rule.